Hi everyone, in today's presentation, we will be discussing the structure and functions of database objects. What are views and their types and advantages? Views are virtual tables created from an SQL query and act as saved queries that can be used as normal tables. They present the data from tables without storing it and are useful when using complex joins as they simplify complex queries. They also provide extra security as they allow the users to see specific columns or rows authorized for them to access. There are many types of views, and they can either be read only or updatable. These include simple views, which are used on single tables and can be updated. There are complex views that involve multiple tables, joins, and aggregations and are read only data, as updating is complex and can affect other data in the tables. Materialized views store the results of a query physically, and non materialized views store and generate query results dynamically. Some advantages of views include simplifying complex database queries, improving security by restricting access, ensuring consistent data access, and providing logical database independence. Views also improve usability by hiding complex table relationships and presenting simplified data structures. However, this can introduce performance overhead as databases scale and grow larger and more complex, maintaining multiple views and their dependencies becomes more challenging. Also, complex views limit data modification if it's read only. How functions and stored procedures are used. Functions and stored procedures are used by developers to implement reusable logic in the database. Functions are used within an SQL query to perform calculations which return a single value or result. They reduce the need to repeat writing complex SQL code and accept input parameters. However, stored procedures are more complex and include multiple statements. They can execute multiple SQL statements, including conditional logic and loops. For example, a stored procedure can process a car booking by updating many tables with a single transaction. So, what are triggers used for? Triggers are programs that respond automatically to procedures that execute within a specific database. Event occurs and runs automatically when operations such as insert, update, or delete occur on a table. An example is a trigger that records information whenever sensitive data is modified or prevents data from being inserted if it violates defined business rules. However, triggers help maintain data integrity and automate database operations without needing direct intervention. Another important use of triggers is audit logging. So when sensitive information is updated, a trigger can be automatically recorded both the old and new values, which is essential for organizations that require traceability of changes made to data. Comparing materialized and non-materialized views. Materialized views physically store the results of a query within the database, meaning that when the view is accessed, the database does not need to recompute the query, so a faster performance. This makes materialized views useful for larger datasets, complex joins, and aggregation queries. However, the data stored must be refreshed to remain consistent with the underlying tables, introducing maintenance overhead. Non-materialized views, however, don't store data physically. Instead, they execute the underlying SQL query each time they are accessed, ensuring that the data is up to date. However, this approach can lead to slower performances, which lead when dealing with complex queries or large volumes of data. The key difference between the two is that materialized views prioritize performance at the cost of requiring maintenance, whilst non-materialized views prioritize accuracy and real-time data access, but may reduce performance. By understanding this difference, we can choose the most appropriate type of view depending on the system's requirements. So how can views improve query performance, and what trade-offs can this have? Views improve query performance as they provide an abstraction between physical data storage and logical data. They improve security by limiting access to sensitive information and simplifying complex data retrieved from tables and encapsulating complex joins, aggregations with a single view. They allow users to retrieve data using simple queries without needing to understand the underlying database structure, reducing query complexity and improving productivity. However, heavy reliance on views can make database maintenance more complex and longer due to dependencies between views and the underlying tables. Therefore, database designers must be careful and balance these advantages and disadvantages when implementing views within large systems. However, some trade-offs may be that non-materialized views can introduce performance overhead because the underlying query must be executed every time the view is accessed, Also, a heavy reliance on views creates dependency chains in which changes to the base tables require updates to multiple related views. This further increases maintenance overhead and leads to system errors if not managed properly. Materialized views also have trade offs like increased storage requirements and the need for regular refresh operations to maintain data accuracy. Overall, while views are a great tool for improving database design and performance, developers must carefully balance their advantages against potential drawbacks. With effective use of views, we can ensure optimal performance data integrity within the system. Thank you for listening.